In this physics project, I'll be going over two videos I performed with my longboard and how it relates to momentum, angular momentum, and possibly more. First, I'll jump on my longboard while it is already in motion and analyze what is happening there. This is often done because it helps get a speed boost, as we'll see in the video. Secondly, I'll do what they call a nollie 180, which is where I turn 180 degrees while still going in the same direction. This one may be a little harder to analyze everything that is happening, but there are parts we have also talked about within our class. Starting off with the video where I jump onto the longboard, we need to answer the question of where the speed boost comes from. First, we have to get some numbers to work with here. Using my scale at home and turning it to SI units, my weight is 87.0 kilograms, and my weight while holding the longboard is 90.9 kilograms. This means the longboard weighs about 3.9 kilograms. The formula for an inelastic collision is shown here. We also need to approximate the speed of me and the longboard beforehand and then compare it to what we see after I land on it. Doing some calculations, I know I recorded the video at 240 FPS, and here I've slowed it down by a factor of 8 and made it 0.125 times the speed. This is about 30 FPS. I start the clip at 102 inside this project, and then the board reaches the crack in the video at 1 minute and 12 seconds. We see that my longboard traveled the distance in 10 seconds or 300 frames, and my body enters the screen around 1 minute and 10 seconds and the crack about 1 minute and 15 seconds into the video. This means it traveled that distance in 5 seconds or 150 frames. This information tells us that my velocity is twice the amount of the board. Plugging these values here on screen, we can see that the final velocity after the inelastic collision is twice as much as the initial velocity of the board. This makes sense because the person running can increase their speed easier off the board than on the board while on flat ground. In addition to this, the weight of the person is much larger than the weight of the board, causing the weight of the board to not affect the equation that much. Now, let's compare this to the original video at the original speed, and we can clearly see that the board seems to approximately double its speed. First, let's analyze the video here. I start by putting my arms out to help balance myself. In the longboard or skateboarding community, we would also use the term momentum to describe how my arms rotate to help guide me. Let's see if the community knows what they're talking about. Let's look at the video again even slower and try to notice some things. First, I see that the arms move, causing a torque on the board. Secondly, the axis is the front wheel of the board. And thirdly, I notice that the axis actually stops moving during the motion. Looking even closer at the wheels, we can see that the front wheel doesn't just stop moving, but instead actually is in the process of changing directions. We can also see the back wheel does the same, except this happens after it reaches the ground. This is likely due to a force not as easily seen here, which is the torque coming from my body. Here's the same clip, but zoomed in even closer to that front wheel, which becomes the back wheel after the trick. Starting with my arms, which is what riders are told to do when first learning this trick, these arms cause a torque that causes an imbalance for the rider. This imbalance is actually very helpful when doing this trick. This imbalance travels down to the feet where the main part of the trick happens. This causes the front foot to want to move in a way that creates another force on the board. The front foot moves in the same direction as the arms moved moments ago, causing a torque to the board. This is the product of the force applied to the foot, the distance between the foot and the axis of rotation, which is between the front wheels, and the angle at which the force is applied. What is so cool about this trick is that the original imbalance allows the foot to easily move in a way that is almost directly on the plane of rotation, which maximizes the effect. With both of these tricks, we ended up seeing a variety of concepts. First, we saw properties of an inelastic collision and how the properties of momentum play into something longboard and skateboard riders do all the time. Then we analyzed a much more complicated action on a longboard and analyzed the forces in action with an emphasis on the effect of the torque. There are many more concepts that we could discuss with this, such as the effects of gravity on the different tricks, or even just studying the linear motion of the wheels. One concept I would be interested in looking at more in depth in the future is why the wheel stopped moving in that second trick. Overall, this was a great project and learning experience that produced a much better understanding of something I enjoy in the real world and why it works.